A very good morning to all of you. Now we are moving to third module. So third module, our course outcome is understand the fundamentals of knowledge representation, inference and reasoning. For this module, mainly I am following the textbook Elaine Rich and Kevin, Artificial Intelligence, the second textbook. So in this session, we will discuss what is knowledge-based agents. Now we will see knowledge-based agent. How does a Google Assistant know when to answer, when to search, when to say I don't know? So such systems store knowledge about the world and reason with it. This is exactly what a knowledge-based agent is. So we have already seen what is an agent in module 1. An agent perceives through sensors, acts through actuators. An intelligent agent means that reasoning to decide actions. So a knowledge-based agent is intelligent because it reasons using stored knowledge, not just rules and conditions. For example, we can say a doctor agent. So doctors store knowledge. So if a fever plus cough, that means flu. Then the doctor adds new information. If a patient comes, the patient has temperature 102 degree Fahrenheit, then the knowledge add new information. Uh, Doctor adds this new information. Then the doctor queries knowledge. What disease matches these symptoms? So here, the agent does not memorize answers, it reasons them out from the knowledge base. So what is a knowledge base? A knowledge base is a collection of facts and rules about the world. A knowledge base contains sentences. A sentence is a formal sentence, not English, but logic based. So each sentence expresses an assertion about the world. For example, if we are considering, if we have a sentence, uh, Socrates is a human. So here it will be written like this. Socrates is a human. So here you can see that this is the logic representation. Socrates is a human. And then all humans are mortal. So then it can be read right like this. Human of X means mortal of X. We will study in detail this type of representation. So here, these are sentences. Socrates is a human and all human are mortal. So these are sentences, they are written in knowledge representation language. So they describe what is true in the world. The computer cannot understand natural language directly for reasoning. So we use knowledge representation languages like proposition logic and first order predicate logic. We will discuss these in detail in this module. So when we are representing knowledge, the language must be unambiguous, logical, and it should be machine processable. So this helps the agent infer new knowledge. So here there are a way to add new sentence to the knowledge base and a way to query what is known. So the standard name of these operations are tell and ask respectively. So here the tell means add a sentence to the knowledge base. Then ask means ask a questions to the knowledge base. And both these operations may involve inference. So this is deriving new sentence from old. We can see one example, that is a smart home agent. So smart home agent is a knowledge based agent and that observes the environment, that is temperature, and uses stored knowledge and takes intelligent action. That is here action is turning on or off AC. So the knowledge base store rules and facts about the world. So here we can see that knowledge base has first one is rule. Here you can see this is the rule we have. If temperature is greater than 30, then turn on AC. So this is a rule. This represents general knowledge and written in logical form. And then we are adding the current information. So that is agent perceives the environment and it get a current temperature is equal to 32 degrees Celsius. So this is actually a fact. This is a fact. So it is added to the knowledge base using tell. Then the agent asks the knowledge base using ask, it will ask, should AC be turned on? So the agent does not guess, it checks whether the query can be logically derived. So here you can see that the current temperature is 32 degree and we have a rule temperature is greater than 13 degree, then turn on AC. So here since 32 is greater than 30, the condition is true. Therefore the conclusion is derived. This process is called a inference. That is yes, turn on AC. So the inference result is yes and the action is turn on AC. The conclusion was not directly stored. It was logically inferred and the agent then acts based on the rule and facts. This slide explains how a knowledge-based agent works internally every time it is activated. So the agent follows a fixed three-step cycle. So that is first tell, then ask, then tell and act. So first we will see tell. Tell actually updating the knowledge base. So each time the agent program is called, it first tells the knowledge base what it perceives. So we already discussed agent has sensors and sensors observe the environment and whatever the agent perceives is added to the knowledge base. For example, here you can see that sensor input is obstacle detected ahead. So then the operation is tell the knowledge base that obstacle is detected. So obstacle ahead is a logical here this is the logical sentence and it becomes a fact in the knowledge base. And knowledge base now knows that an obstacle exists. So here the tell does not decide anything, it only updates the knowledge base. Then next is ask. So it asks the knowledge base what action it should perform. The agent now needs to decide. So it queries the knowledge base. So this triggers reasoning and inference. So it will write a query. You can see here, ask knowledge base, what action should I do? So the agent reasons about current world state, possible actions and possible outcomes. So this reasoning may be simple or complex. So decision making happens during ask using inference. Then the third step. The third step, the agent program tells the knowledge base which action was chosen and execute the action. So again we have a tell knowledge base and action is equal to turn left. So the chosen action is executed in the environment and stored in the knowledge base for future reference. So this helps the agent avoid repeating mistakes or reason better in the future. So the knowledge base stores past actions also, not just facts. So here we can say that here the steps is first is perceive, then tell, then ask, then infer, then act, again tell. So this cycle repeats. So this is why agent is dynamic and intelligent. So a generic knowledge-based agent operates in three steps. First, it perceives the environment and update the knowledge base using tell operation. Second, it queries the knowledge base using ask operation to decide the appropriate action during which inference is preferred or performed. Then the third is the selected action is executed and the knowledge base is updated with the chosen action. So this continuous cycle enables intelligent behavior. So this is the internal working algorithm of a knowledge-based agent. So every time agent receives a person, it decides one action using its knowledge base. So this is a normal program. It represents a reasoning behavior. here you can see that here we have a function that is a agent AB underscore agent function. So, and there percept as the input. Percept means what the agent senses now, and it returns an action. Action means what the agent will do next. And here the percept, for example, you can see obstacle ahead. An action may be turned left. Then persistent, that is knowledge base. Then KB is the knowledge base. So there we can store facts, rules, and past actions. Then persistent means the knowledge base is not cleared after each call, so it remembers past knowledge. Then there is a time counter T that tracks time steps, and it helps to represent sequence of events, past versus present knowledge. So persistent allows learning over time. Then next step one, that is tell, that is adding the percept. So here it converts new sensor input into logic sentence and add it to the knowledge base. So then the perception becomes the knowledge. The second step is ask. So ask what should I do at a time t. So here you can see that the t is also mentioned. The knowledge base uses stored facts, rules, and inference. And ask triggers reasoning and inference. Then again we have next operation is tell. So that is storing and chosen and storing the chosen action. So the selection action that is stored in the knowledge base and that is used for future reasoning. So this enables history based reasoning. Then next step is time update. T becomes T plus 1. So it moves to the next time step and ensures the correct sequencing of events. Next is return action. So the agent executes this action in the environment. So we can say that the cycle is first there is a first step is percept. Then next is tell. So tell is for update knowledge base. Then ask, that is the third step, that reason using knowledge base. And then there is a inference, and then corresponding to then corresponding action. Then again tell. So that means tell store that new action to the knowledge base. We know that AI systems solve complex problems, not the simple calculations. To do this, they need knowledge and a way to use the knowledge. So, for human intelligence, it has knowledge and reasoning. And for AI intelligence, will be a knowledge base and also a inference mechanism. So, hence the knowledge representations becomes essential. So there are two requirements for solving an AI problem. First one is large amount of knowledge and second one is mechanism to manipulate knowledge. So the large amount of knowledge includes facts about the world and also the rules and relationship. And the mechanism to manipulate knowledge means there will be logical reasoning, inference and drawing new conclusions. So storing knowledge alone is useless unless the system can reason with it. So we can see that what is knowledge representation. We can say that knowledge representation is a method of encoding facts about the world, about the real world into a form that a computer can understand and manipulate. So there are two kinds of entities in knowledge representation. So that is first one is fact and the second one is representation of facts. We will see. First one, fact. So fact exists in real world. They are true statements and the human understand them naturally. For example, I can say that sky is blue, fire produces smoke are the real world facts. Then representation of facts means computer cannot directly understand natural language. So the fact must be converted into formal language. So we have already seen Socrates is a man. So same way here you can see the sky is blue. We are representing like this. Here you can see sky of blue. Then fire produce smokes. this we can represent it as fire of X produce smoke of X. Fire of X implies smoke of X. So these representations can be stored, queried, and also used for inference. So here, in this case, you can see the sky is an object, and this blue is a property. So this is a predicate representation and easy for the system to store and use. So this fire of X implies smoke of X means here X is an object, X is any object, and X is a fire. This means fire of X means X is a fire. And here smoke of X means X produce smoke. And this implies, this is the imply symbol. And this imply symbol, that is the implication. So that is related to if then rule. So if something is fire, then it produces smoke. So the representations are how we tell the computer what we know. So actually, for a good representation that makes the reasoning easy and also that will support the inference, so that will improve the AI performance. And if the representation is poor, so that leads to a complex reasoning and also the inefficient AI system. So in AI, solving complex problem require large amount of knowledge and mechanism to manipulate the knowledge. And the knowledge representation deals with encoding real world facts into formal structure, and that can be processed by a computer. And we have already seen what is facts, and that is the true real world statements and the representation of facts, which are formal expressions used by an AI system. Then there are two levels of knowledge representation. In AI, we talk about the knowledge at two different levels. So one level is what the agent knows. The other level is how the computer stores and processes it. So first one, knowledge level. So knowledge level describes the facts about the world in human understandable way. So that is concerned with meaning and that is independent of programming language. So that describes objects, properties, relationship and rules. For example, we have already seen sky is blue, fire produce smokes. So if it rains, the road become wet. So at this level, we only care about what is true and not how it is stored. Then second one is symbol level. Symbol level means that describes how knowledge is represented internally using symbols that a computer can manipulate. So that uses symbols, predicates and logical expressions. This is here the symbol level, the program operates and the inference is performed. So here we have seen a sky of blue. That is an example of symbol level. We have already seen that. Then fire of smoke implies smoke of X. So the symbols have no meaning by themselves unless we interpret them. So knowledge level means what is true in the world, and symbol level means what it is encoded in the machine. So knowledge level is semantic and symbol level is syntactic. So here, why these two levels are needed or important? So human think at a knowledge level and computer works at a symbol level. So AI system connect both levels to behave intelligently. So, so there should be a correct mapping between these two levels is very crucial for a good AI design. We will see the mapping between facts and representation. So AI system work with the symbols, but the real world consists of facts. So we need a mapping between the real world facts and the internal symbolic representation. So this connection is called a representation mapping. Here it's a two-way representation. The figure we can see that it's a two-way representation. So the facts and representation are linked with the two-way mapping. mapping is not in one direction. So that means we have to convert facts into symbols and convert symbols back to facts. So this is why it is called a two-way representation mapping. And here we can see that forward representation and backward representation. Forward representation mapping converts real world facts into internal symbolic representation, and that is this part, facts to internal representation. Then um, then we can say here forward mapping answers how do facts enter the knowledge base. So human state facts in natural language and AI converted into logic symbols, and this step enables the reason. And then backward representation. Backward representation mapping converts internal representation uh, mm, back into actually facts and conclusions. So after reasoning, AI produces symbolic results, and these must be translated back into human understandable facts, actions, and also the explanations. So the backward mapping answers how do we understand AI's conclusions. So here in this figure, we can see that there is a fact, they are real world truths. Then there is a forward mapping that converts facts into symbols. This is forward mapping, converts into symbols. Then there is an internal representation used by the reasoning programs. Then there is a reasoning program is there. So that is used to, that is actually apply rules and inference. And then corresponding backward mapping that converts the result into final facts. And then English generation means that produces human readable output. So this shows the complete reasoning loop. Then here, same figure, here you can see there are initial facts that is converted into internal representation, that is called forward representation mapping. And then um, this is actually a symbol level. Now AI can manipulate these expressions. Then operations on program. So that is inference. Then we have the backward representation, that is from internal representation to facts, that converts symbolic conclusion back to facts. This is the final fact derived by reasoning. And here reasoning happens only at the symbol level, but correctness is judged at the knowledge level, that is fact. So here, without this forward mapping, the AI cannot understand the world. And without backward mapping, AI conclusions are meaningless to the human. So this mapping is very important. And proper mapping ensures the correct reasoning and also the explanation for the AI result. So here we can see the example. Spot is a dog. This is a fact. And here, then every dog has a tail. That is also a fact. These are the initial facts. And then after forward mapping, this is converted into internal representation. So that is symbol level. So symbol representation, you can see dog spot. So this is the symbol level representation, and also every dog has a tail. You can see that this we will discuss in detail. This is for representation of all we are putting this. For all x, dog x means has tail x. So dog x implies has tail x. If X is a dog, then X has tail. So this is the symbol level representation or internal representation. Then after the operation of program, it will conclude that sport has tail. So here X can be sport. So if X is sport, then sport has tail. That means sport has a tail is the conclusion. So this is the final fact derived by reasoning. Next, we will see the properties of knowledge representation system. A knowledge representation system is must satisfy certain properties so that an AI system can store knowledge, reason effectively, and learn efficiently. So, a knowledge system is not useful just because it stores knowledge. It must also support reasoning and learn effectively and also reason effectively. So here we will see four essential properties. First one is representational adequacy. So the ability of a knowledge system to represent all required type of knowledge in a given domain. So the system should represent facts, rules, relationship, and also the constraints. If something cannot be represented, it cannot be reasoned about it. For example, in a medical AI, we have to represent symptoms, diseases, causes, and treatments. If the system cannot represent symptoms severity, it is inadequate. So if you cannot represent it, you cannot reason about it. Next is inferential adequacy. So that is the ability to derive new knowledge from the existing knowledge. So using inference rules, uh, this knowledge representation that must support logical inference, rule application and deduction. So for example, if a dog, we have already seen that dog is a sport and for all dog has tail. So from that we have the inference sport has tail. So here this new fact was not explicitly stored but it was inferred. So that means inferential adequacy enables reasoning and conclusion generation. So next is inferential efficiency. This is the ability to perform inference efficiently by guiding the reasoning process towards relevant knowledge. So in the case of a large knowledge base, it contains thousands of facts. So reasoning on the facts will be slow. So knowledge representation will help reduce search space and also focus on the relevant rules. So we know that in the case of a chess, focus only on legal moves. And in medical diagnosis system, consider only symptoms related to that disease. So we have to focus on the relevant rules. So not just correct inference, but that should be fast and focused inference. Then next is acquisitional efficiency. So the ability of a knowledge representation system to easily acquire new knowledge, preferably automatically. So here knowledge should be added easily, learned from the data and also updated with the minimal human effort. For example, learning new rules from data, updating knowledge base from sensor input, machine learning system updating knowledge automatically. So we can say that for an ideal knowledge representation system that control their own knowledge acquisition. So we have seen the four properties. First one is representational adequacy, that is what can be represented. The purpose is what can be represented. And inferential adequacy means what can be inferred. Inferential efficiency means how fast and focused inference. And then acquisitional efficiency means how easily new knowledge is learned. So we can say that a knowledge representation system must satisfy certain properties to support intelligent behavior. We will see the different approaches to knowledge representation. First one is simple relational knowledge. The simple way to represent knowledge is the same way we store data in a table or a database. We can see in the table here. So here, simple relational knowledge represents facts using tables where each row is a fact and each column is an attribute. So here we will see some of the points. Simple way to store facts is we can, that means here facts are stored directly and there is no complex structures and it is very easy to understand. Here the first row, from the first row we can understand that Peter is a right-handed and his weight is 180 and his height is 6 inches. So here it uses a set of relations like a database, that is each table shows a relation and each row represents a fact and each column is a attribute. So AI system reads knowledge like a database and facts are organized systematically in columns. Here we can see these are the attributes: player, height, weight, and handed. So it is very structured and easy to query simple facts. So here, who is left-handed? If the query is who is left-handed, then we can simply answer Ajay and John. So it may serve as the input to more powerful inference engine. So table alone is actually weak, but it can be converted into logic. So yeah, it provides very big inferential capability actually. So that means it can answer direct questions only. So it cannot reason deeply. So if we have a question, which right-handed player can best face a particular bowler, then it fails to infer that question. So that means the table has height, weight, and handed, but there is no rules, no relationship, and there is no domain knowledge. So the system cannot compare players and apply strategies and draw conclusion is difficult here. It stores facts but not the reason. So here we can say that this simple relational knowledge is simple, easy to implement, and fast data retrieval, and also it is similar to database. But the advantages means it is a very limited reasoning, and there is no inference rules, and cannot handle complex knowledge. Next is inheritable knowledge. So in many real world domains, objects share common properties. So instead of repeating the same information, AI uses inheritance. So this leads to an inheritable knowledge approach. So all data is stored in a hierarchy. That means all classes should be arranged in a generalized form. It's similar to a object-oriented programming. So in this approach, we apply inheritance property. So for the properties actually defined at higher levels are inherited by the lower levels. Then the representation for there are different approaches are there for representation. There is a frame representation or semantic representation is there. We will discuss these representation in detail in the later slides. So here we can see the example. In this figure, each box that is a frame and that represents object, class or instance. For example, person is a class, then baseball player, picture, three finger brown, it's an object. So, and the arrow shows the relationship. So here you can see that there is a, it is written is a. So is a means subclass or a class membership. And then instance, here you can see instance. Instance means object belonging to that class. So PV is an object belonging to the class fielder. And then you can see height, uh, batting average, bats. So these are attributes. It has value. You can see height 5 to 10, then 6.1, batting average 0.252. It has value. Then you can see team. Team shows the relationship. So that means uh, this three finger brown is belonging to Chicago clubs. PV Reese is belonging to Brooklyn Dodgers. So arrow connects object to their values. Each frame has slots, that means attributes, and fillers. So fillers means value. So this is called a slot and filler structure. And also we can call it as a semantic network or a collection of frames. Here the frame is, can consider the baseball player is a frame and the slot is height and its value is 6.1. So here if a value is not present in a frame, the system looks up the hierarchy. So, for example, uh, we know the baseball player how it bats. So it's not there is no and here you can see that it bats equal to 100. So it is written it is equal to 100. So we know that baseball player is an adult male, is a person, and it is handed right. So we can say that baseball player bats right-handed player. Then here we know that pitcher bats it is not in this figure. So it actually it inherits baseball player. Pitcher inherits baseball player. it is inherits adult male, it inherits person, so it is a right-handed, mm, it backs right-handed. So here, for example, class picture is a class, and its instance is three finger brown. So three finger brown instance of a picture. So this instance inherits all the attributes of picture. And picture inherits baseball means it inherits all the attributes of baseball player and all the attributes of adult male and then all the attributes of person. Then next we will see algorithm for here the algorithm to retrieve a value for a attribute of an instance object. So first step is find the object in the knowledge base. If the attribute value exists, then return it. Else check the instance and else go to the parent class and continue moving upwards using a is a until found. Uh, is a what we have already discussed in the previous slide. Then here we will see an example. This is the figure. Animal has head. Uh, reptile is a subclass of animal. Mammal is a subclass of animal. Then elephant is a subclass of mammal. And elephant lives in Africa. Its size is large. And Nelly is an instance of elephant. And Nelly likes apples. This is the figure. So Nelly is an instance of elephant. Elephant is a subclass of mammal. Mammal is a subclass of animal, and animal has part head. So here the question is, where does Nalli lives? Then we will check where is Nalli. Nalli is here. So Nalli lives is there. There is no direct answer. So we can say that Nalli is an elephant. Nalli is an instance of elephant, and elephant lives in Africa. So we can say that Nalli lives in Africa. Does Nelly has head? Nelly has head. There is no attribute called head here. So what we will do? Nelly is an instance of elephant. Elephant is a subclass of mammal. Mammal is a subclass of animal. Animal has head. So we can say that Nelly has head. Next is inferential knowledge. So inferential knowledge is the ability of an AI system to generate new knowledge from the existing knowledge without asking for new data. So there are no new data collection, only reasoning and analysis. So here, this knowledge generates new information from given facts, and it uses logical reasoning, and it does not require further data gathering. It requires only analysis of the existing information. So AI behaves like a human reasoning logically. So, for example, if we know some relations and values, we can infer other relations or values. For example, if A is a parent of B, so if we have A is the parent of B, and this is the parent. Then B is the parent of C. Then we can infer A is grandparent of C. A is grandparent of C. A is the parent of B. B is the parent of C. Then we can say that A is the grandparent of C. So this is inferential learning. So here inferential knowledge mainly uses predicate logic, so which is a form of mathematical deduction. So we will discuss in detail. So predicate logic actually help us to represent objects, represent relationship, and apply logical rules, and also derive new conclusions. In inferential in knowledge, we are using logical operations, that is inference through predicate logic. We will use and operator, or operator, not operator, implies universal quantifiers and existential quantifiers. We will discuss that all in detail. So here we can see an example. We have a sentence, all dogs has tails. So we will represent for all, we will represent uniform quantifier. This is a uniform quantifier. it is used for representing all. For all x, if x is a dog, that implies x has tail. So for all x, this is for all x, and this means x is a dog, and this means x has a tail. So this is the formal logic representation. So it's here we can see the advantages. It uses a set of strict logical rules, help to derive new facts, and truth of new statement can be verified, and also it guaranteed the correctness. So if premises are true, then if the premises are true and inference rules are valid, the conclusion is always correct. So we can see one example. Uh, man Marcus is a man. So here we can represent like this: man Marcus. Then all men are mortal. So for all we will represent unifier quantifier. So for all x, x is a man. That means x is mortal. So all men are mortal. For all x, x is a man. Then x is mortal. So this is the new knowledge derived without the new knowledge. Marcus is a man, and uh, all men are mortal. So what will be the inference here? Here inferred conclusion is actually we can write uh, Marcus is mortal. So here we can conclude it as mortal Marcus. So because here we know that Marcus is a man, and for all x, if x is Marcus, then x is mortal. So we can write mortal. Next is procedural knowledge. So procedural knowledge, do we always need to store facts, or we can we store steps to solve a problem? Is it possible? Procedure knowledge represents how to do things, not just what is true. So here procedure knowledge is represented using procedures, programs or rules that describe how to perform a task or reach a solution. So here knowledge means action plus control. So that means it can stored as code, procedures or rules. So there we use if then rules. So the core of procedure knowledge is the if then rules. So if temperature is greater than 30, then turn off AC. So if is the condition, then is the action. So this directly tells the system what to do. So there are different languages can be used, Lisp, prolonged rule-based system and all. So it supports, these languages support symbolic processing, and also it is easy to encode rules and procedures. So the procedure knowledge is very good for representing heuristics. In the case of chess, if opponent king is exposed, then attack. In diagnosis, if you were press up, then it may be flu. So these are experience-based rules, not universal rules. So the advantages of procedure knowledge is that it is easy to implement and direct execution, and also it is efficient for specific task actually, and it is suitable for expert system also. But there are limitations. It is not necessary that we can represent all the cases. Knowledge can be hard coded and it can be task discussed. Then it is difficult to modify, reuse, and also explain. The system knows how, but not why. So it is actually focusing only on how to do things, and it will represent if then rules. And here the explanation ability is poor. Next, we will see the issues in the knowledge representation system. The main goal of knowledge representation system is to facilitate inferencing, to draw conclusions from stored information. So the knowledge should not be just not stored; it should be usable for reasoning and decision making. But while doing this, several issues or problems may arise, which we will discuss. First one is important attributes. That is, which attributes objects are so basic that may appear in almost every problem domain. So objects may have attributes, but not all the attributes are equally important. So choosing unnecessary attributes increases complexity. Then next is relationship among attributes. So that means what important relationship exists among object attributes. Attributes are often interrelated, and this relationship must be represented correctly. That means, if, for example, if age is less than 18, then not eligible to vote. So if experience increases, then salary increases. So the capturing meaningful relationship between attributes for proper inference. The third point is choosing granularity. That is here at what level of detail should knowledge be represented. That is fine-grained or coarse-grained. Too much detail or too little details. Then next point is set of objects. How should set of objects be represented? Knowledge often deals with a group of objects. So there should be an efficient representation for set of objects when we are representing. All students of a class, all employees in a department. So representing collection without redundancy and confusion. And the last one is finding the right structure. So given a large amount of stored knowledge, how can relevant part be assessed efficiently? So knowledge base is very large, so searching everything will be very slow and inefficient. So choosing the correct structure so that the relevant knowledge is retrieved. Thank you.